When wiring a control panel, understanding Underwriters Laboratories or all color codes is crucial for safety and compliance. Regarding direct current or DC conductors that remain energized when the panel is off, the UL standard color is red. This helps electricians and technicians quickly identify potentially hazardous voltage sources, even when the main power to the panel is disconnected. Using the correct color coding reduces the risk of electrical shock and simplifies troubleshooting. Specifically, the consistent application of color coding is essential. It provides a visual cue, allowing personnel to readily recognize the nature of the conductor. This is particularly vital in complex control systems when numerous wires are present. Firstly, let's discuss the importance of color coding in general. Color coding serves as a visual aid, allowing electricians and technicians to quickly identify the function and voltage level of a conductor. This reduces the time required for maintenance and troubleshooting, while also minimizing the risk of errors. Standardized color schemes ensure that anyone familiar with electrical work can understand the wiring configuration, regardless of who initially installed it. Secondly, consider the implications of using the wrong color code. Incorrectly colored wires can lead to confusion and potentially dangerous situations. For instance, if a direct current conductor that remains energized is mistakenly wired with a color typically associated with grounded or neutral conductors, a technician might inadvertently come into contact with live voltage, believing the circuit to be safe. Thirdly, let's delve into the specific requirement for DC conductors that remain energized. The color red is designated by UL standards to indicate that these conductors carry a potentially dangerous voltage even when the panel's main power switch is in the off position. This is because the power source is external and not controlled by the panel's main disconnect. Now, let's think about some practical scenarios where this color coding is critical. One scenario involves control panels that are connected to backup power supplies, such as batteries or uninterruptible power supplies, also known as UPS systems. These backup systems are designed to maintain power to critical components even during a power outage. In such cases, the DC conductors from the battery or UPS will remain energized, and they must be clearly identified with red insulation. Another scenario involves control panels that receive power from external direct current sources such as solar panels or wind turbines. These renewable energy sources may continue to generate power even when the main grid is down. The DC conductors from these sources must also be identified with red insulation to indicate that they are still energized. Furthermore, in industrial automation systems, certain sensors and actuators may require continuous DC power for monitoring or control purposes. These components may be powered by an external DC power supply, and the wiring must be properly color-coded to prevent accidental contact with live voltage. The red color code is not just a recommendation, it is a critical safety requirement outlined in UL standards. These standards are developed by Underwriters Laboratories, a globally recognized organization that tests and certifies products for safety. Compliance with UL standards is often mandated by local electrical codes and regulations. Moreover, it is essential to understand that the color red applies specifically to direct current conductors that remain energized when the panel is off. Other direct current conductors, such as those that are de-energized when the panel is off, may be wired with different colors, such as blue or white with a blue stripe, depending on the specific function and voltage level. Now, let's consider the implications of using different colors for direct current wiring. Firstly, conductors that are part of intrinsically safe circuits are often identified with a light blue color. Intrinsically safe circuits are designed to limit the amount of energy available, preventing ignition in hazardous locations. The light blue color helps to distinguish these circuits from other direct current circuits. Secondly, grounded or negative direct current conductors are typically identified with white or gray insulation. This is consistent with color coding used for alternating current systems, where white or gray is used for the neutral conductor. Thirdly, direct current conductors that are switched or controlled by the panel's main disconnect may be wired with other colors, such as black, brown, or orange, depending on the specific function. However, it is essential to clearly label these conductors to indicate their voltage level and function. To summarize, the key takeaway is that red is the designated color for direct current conductors that remain energized when the panel is off, regardless of the source of the power. This color code is a critical safety measure that helps prevent electrical shock and simplifies troubleshooting. It is important to note that electrical codes and standards can vary depending on the location and application. Therefore, it is always recommended to consult the latest edition of the National Electrical Code (NEC) and any applicable local codes before wiring a control panel. The NEC provides comprehensive guidelines for electrical installations, including color coding requirements. In addition to color coding, it is essential to use proper wiring techniques and hardware. This includes using appropriately sized conductors, making secure connections, and providing adequate insulation and protection. Furthermore, proper labeling of all conductors and components is crucial for safety and troubleshooting. Labels should clearly indicate the voltage level, function, and destination of each conductor. This will help prevent errors and ensure that maintenance personnel can quickly identify and address any issues. Moreover, regular inspection and maintenance of control panels are essential for ensuring their continued safe and reliable operation. This includes checking for loose connections, damaged insulation, and other signs of wear and tear. Any problems should be addressed promptly to prevent potential hazards. Let's explore some additional best practices for wiring control panels. Firstly, always disconnect power to the panel before beginning any work. Verify that the power is off using a reliable voltage tester. Secondly, use appropriate personal protective equipment, including safety glasses, gloves, and insulated tools. Thirdly, follow a consistent wiring method and layout. This will make it easier to trace circuits and troubleshoot problems. Fourthly, use cable ties or other means to bundle and secure wires. This will prevent them from becoming tangled or damaged. Fifthly, keep the panel clean and free of debris. This will help prevent overheating and other problems. Sixthly, document all wiring changes and modifications. This will ensure that there is an accurate record of the panel's configuration. Seventhly, test the panel thoroughly after completing any work. Verify that all circuits are functioning properly and that there are no shorts or ground faults. In conclusion, understanding and adhering to UL color codes is essential for safe and compliant control panel wiring. By using the correct color coding, you can help prevent electrical shock, simplify troubleshooting, and ensure the reliable operation of your control systems. Remember that red is the designated color for direct current conductors that remain energized when the panel is off. Always consult the latest edition of the NEC and any applicable local codes before wiring a control panel, and follow all safety precautions to protect yourself from electrical hazards. Furthermore, meticulous attention to detail, adherence to best practices, and ongoing maintenance are critical for ensuring the long-term safety and reliability of control panel wiring. Consider these points to further amplify your understanding. Firstly, familiarize yourself with the specific requirements of the application. Different industries and applications may have unique color coding and wiring standards. For example, the color coding requirements for a control panel in a hazardous location may be different from those for a control panel in a general-purpose location. Secondly, consider the use of wire markers or labels in addition to color coding. Wire markers can provide more specific information about the function and destination of a conductor, especially in complex control systems with numerous wires. Thirdly, be aware of the potential for color blindness. Some individuals may have difficulty distinguishing between certain colors. Therefore, it is important to use color combinations that are easily distinguishable by people with color blindness. Alternatively, wire markers with text or symbols can be used to supplement color coding. Fourthly, train all personnel who work on control panels in proper color coding and wiring techniques. This will ensure that everyone understands the importance of following established standards and procedures. Fifthly, periodically review and update your color coding and wiring standards to reflect changes in technology and regulations. This will help ensure that your control panels remain safe and compliant. Electrical work can be dangerous if not performed correctly. Therefore, it is always recommended to hire a qualified electrician or technician to wire or modify control panels. A qualified professional will have the knowledge, skills, and experience necessary to perform the work safely and in compliance with all applicable codes and regulations. And while we're on the topic of control panel wiring, it's beneficial to understand the broader context of electrical safety standards and regulations. These standards are not static, they evolve over time to incorporate new technologies, address emerging hazards, and improve overall safety. Staying informed about these changes is crucial for anyone involved in electrical work. One important aspect of electrical safety is arc flash protection. An arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical system. Arc flashes can cause severe burns, injuries, and even death. Control panels are particularly susceptible to arc flash hazards due to the high concentration of electrical components and wiring. Therefore, it is essential to implement appropriate arc flash protection measures such as using arc-resistant equipment, wearing personal protective equipment, and following safe work practices. Another important consideration is grounding and bonding. Grounding and bonding are essential for preventing electrical shock and minimizing the risk of fire. Grounding provides a path for fault current to flow back to the source, causing the circuit breaker to trip and to energize the circuit. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. Proper grounding and bonding are critical for ensuring the safety of personnel and equipment. In addition to these technical aspects, it is also important to foster a strong safety culture in the workplace. This includes providing regular safety training, encouraging employees to report hazards, and recognizing and rewarding safe behavior. A strong safety culture can help prevent accidents and injuries and create a safer work environment for everyone. Ultimately, electrical safety is a shared responsibility. Everyone involved in electrical work, from engineers to electricians to technicians, must take responsibility for their own safety and the safety of others. By following established standards and procedures, using proper equipment and techniques, and fostering a strong safety culture, we can all help prevent electrical accidents and injuries.